Hey everyone, GrafDBA here with another video, and today I'm going to be looking at developing a performance dashboard for my Oracle database using Grafana. But first, some legal bits and pieces. I'm not going to drain this slide, but the important bit is that I work for Dell. That said, any opinions expressed in this video are entirely my own and may not reflect the opinion of Dell Technologies. Okay, Grafana. I took this from Wikipedia, as you can see. Grafana is a multi-platform, open-source analytics and interactive visualization web application. It comes in two basic flavors. One you pay for, the Enterprise Edition, and one you don't. I'm not sure what I'm supposed to call the free version, so I'm just going to call it the free version. The Enterprise Edition includes a wide variety of connectors to access different data sources. For example, with the Grafana Enterprise Edition, you can directly access an Oracle database from within Grafana. The free version is much more limited, with the two main connectors being Postgres and Loki. There is no Oracle connector in the free version of Grafana. But what we can do is interrogate an Oracle database, capture the key statistics, insert them into a Postgres database, and then use that to drive our Grafana dashboard. This video accompanies two blog posts and a GitHub repository I put together that explains how to scrape the Oracle statistics, calculate the deltas for metrics that are cumulative, and then insert the results into Postgres. In this video, I'm going to show how to read that data and format some simple graphs in Grafana. So let's get started. First, I need to connect to my Oracle database and read those key OS metrics from inside the database. And to do that, I'm going to need to look at the $OS stat view inside of the database there. This is the one that contains all of the key operating system metrics that I want to go and query. Now, I'm going to connect to this view a total of 10 times because I'm reading 10 different metrics off of that view. And I'm ordering by the instance ID because the $view will have one entry for each active node of my database. So if I connect to my 2-node Oracle RAC cluster and run my query here, I get two records back, one for each node of my cluster, and as you can see, it's crafted it as an insert statement for my Postgres database into a table called OS stats, and there we've got all the values of the metrics that we're going to be reading. So now let's go and connect to Postgres. And I should be able to take these two records that I got back and insert them into my table inside of Postgres. Several of the metrics that I inserted are cumulative values. Values such as systime and idle time are in fact the sum of the ticks of that metric since instance startup. So if we were to calculate overall idle percentage based on these values, we would in fact get the average idle percentage of the database host since instance startup. Now that's not what I want to know. So I need to calculate the delta between this collection that I just inserted and the previous one. This SQL does just that. It runs in Postgres and it takes the last set of metrics inserted, subtracts the value of the previous metric, and inserts the delta into a second table called OS stats delta. It is this delta table that Grafana will read to render the dashboard. So I'm going to take that piece of SQL, I'm going to run it against my Grafana database, and now it's generated me a delta table, a delta record, and if I select from my delta table, we now have the metrics, the operating system metrics from the Oracle database host as they changed over time, stored in our Postgres table. All right, I've logged into Grafana here, and now I'm going to go ahead and create that new dashboard. So I'm going to click on the arrow up here that points right, and I'm going to select a new dashboard, and I'm going to add a new panel. And first off, I'm going to set my data source to my Postgres database. So I've already set this up. And having done that, I'm now going to select my control, my graphical control, to be a bar gauge. And I'm going to select from that OS stats delta table in my Postgres database. And you'll notice it already tells us that the time column does not exist. That's because we named the time column TS. So we'll select that. And in the column value, I'm going to pull up that IDL value, idle value, And you'll notice that Grafana prompts us with the columns that it finds. And now we can see that Grafana has responded by giving us a result here of a very large number. That is the idle ticks that it is finding in the Aura OS stats delta table. So what we want to do though is we want to know what percentage idle that is. So I'm going to click on the Edit SQL button. And I'm going to divide the idle value by idle plus busy. And then I'm going to multiply the entire result by 100. And if I click on the enable query, it tells us that it is 99.6% idle on that collection. Which, if we compare that to our database host, we find that yes, indeed, our database host is in fact about 100% idle. Okay, so what we need to do next is to create a process that will continuously refresh those statistics in our Postgres database. So I've written a simple Corn shell script that basically goes and grabs that data and waits 5 seconds and then goes and refreshes it. So there's a continuous stream of data coming into Postgres, giving us up-to-date information about every 5 seconds or so. And we can now also set our dashboard to refresh on a regular basis as well. So as the numbers change over time, we should see our dashboard start to refresh. There we just saw a little bit of a change. So what I'm now going to do is I'm going to go into my dashboard and I'm going to add some additional columns here to the data that I'm pulling. And I prepared this earlier, as you can see. So basically we're pulling percentage idle, percentage system load, percentage of user load, and also the percentage of I/O weights. Now you'll notice I made a couple of additional changes here. First of all, Oracle, when it calculates the idle time, it actually includes I/O weights within that idle. Linux does not. It quotes it out separately. So in order for our dashboard to match what Linux is going to be reporting, we need to subtract the I/O weights from the idle time. We're also adding this greatest one clause in there as well, because whenever we start to divide, we want to make sure that we never end up with a div by zero condition, which might happen in the event that one of our database hosts goes down. So now I've got my 4 columns. I've got my percentage idle, percentage system, percentage user, and percentage of I/O weights. And over on the right-hand side, I'm going to make a couple of changes here. So first of all, I'm going to delete that threshold. We don't want that. We want the colors to stay consistent. And also, I want the colors to follow a different scheme here, and kind of the classic palette. And I'm going to change the title of my panel here to System Load Node 1, and I'm going to click the Apply button. And now we have a system load on our first node of our RAC database. Now what I can also do here is I can duplicate that panel, and on the second one I will edit it, and I will change this to Node 2, and I will also have to put that down here in my clause. So there we have it. System now is monitoring system loads on nodes 1 and 2. So now if I actually kick off a workload, we have a swing bench here. So if I kick off my swing bench workload, and we should start to see some workload hitting our 2 database nodes. So now we see the system load is increasing. The idle time was dropped from 99 down to 72 and now down to about 64. Now what would also be nice to know is how many users are connected to each of our 2 database nodes. So let's see if we can figure that one out. Back here in the database, I can run a query to report for me how many users are on each node. And once again, we're crafting a Postgres insert statement that's telling us that we have 30 users on node 1 and 30 users on node 2. Now you'll notice on this query, we've also got this on conflict clause, because most of the data that we're going to be reporting is going to be time series data. We may want to graph it over time, but the user count is one that right now I just want to see what it is at this exact point in time. I don't particularly care about historical data. Now in Oracle, we could do an upsert statement. That is to say, insert the record if it doesn't exist and update it if it does exist. In Postgres, the on conflict clause gives us that same functionality. So we're going to be inserting into a Postgres table called RS sessions no time the values of the user counts for each of the two nodes, and if those records already exist, then it will update it to the new setting. Now there is an additional problem here, that if there is no users connected to an individual host, then we will not get any of these insert statements at all. So what we want to do is we want to do a union all clause on this one and check to see if there's any cases where no users are connected at all. And here is that updated query. So now we have a union all to a second clause, which also checks to make sure that there are no cases where there are 0 users connected. And if that finds one of those cases, then in fact we would get an insert statement that reflected that, so that we will actually see that there are no users on a given node should that condition arise. Okay, so I've added that collector to my Corn shell script that's collecting the session data every 5 seconds or so. So we now have a new Postgres table with RS sessions no time that's tracking the number of current swing bench users in my database. So what I can do now is add a new panel, and I will set my data source to my Postgres database. I will set this control up here from time series to a table. And this is not time series data, like we said. This is just going to be a static data. So we're going to set that table. We're going to select our source table to the RS sessions no time. And you'll notice that it still tells us that there's no time column, which we know. So what we're going to have to do is edit the SQL directly. And we can then remove that time select. And then we're going to add in the instance ID. And we will give that the name of database node and the users, so connected users. Okay, and let's see if we can, and there we go, and we'll change the title of this again to connected swing bench users. Apply. Okay, I'll drag that new panel down to be the bottom right. And you can see now that we've got 30 users on node 1, 30 users on node 2, and we have about 65% idle time on each of our 2 database nodes. So now let's watch what happens if we shut down one of our 2 database nodes. So I will go back to Linux and log into node 2. And I have a little helper here to do that for me. And if I go back into my Grafana interface, we just shut down node 2. So in a few seconds here, we should see our swing bench user count change from equally distributed 30-30 to all the users over on one node. And we should see the database loads move accordingly. So we can see that database user loads have all moved over to node 1 now. We have 60 users on node 1, and you'll notice that the system load on node 1 has increased. Our idle time was dropped from around 65 down to around 40. Also, our system and user loads have increased, and also our I/O weights have increased because, of course, we've lost about 1/2 of our I/O paths to the underlying database. But you might notice that the system load on node 2 is still reporting 64%. Now, if we go and compare that to what node 2 actually tells us, if I restart my dstat process, you will see that node 2 is in fact 100% idle. The problem is, of course, is that we're reading Linux operating system statistics from inside of the database. The database itself is down. We're only seeing the last recorded metric, which obviously now is very misleading. So let's go ahead and fix that. I've logged back into my database, and obviously I'm on the surviving node 1, And if I run this query here, I've crafted a query that's going to insert a row into the OS stats Postgres table with basically all zeros in the event that it finds a database thread that is not open. So we're querying the $thread view, we're looking for the status. If it's not open, we're going to put in this down state into the database. And adding that to our script that's refreshing the stats every few seconds, now you can see that the system load on node 2 has dropped all the way down to 0, which is what we would expect. So what happens if we now restart our stopped database node? So we'll go back to node 2, and we have a little helper script here. Bring the node back online. It takes a few seconds for Oracle to start up, but when it comes back online, you should see that the system load node 2 panel starts to update with actually up-to-date statistics from node 2. So node 2 has come back online, and node 2 now is 97% idle. Node 1 is still carrying all the system load, and as you can see, all of our Swingbench users are still connected to the surviving node 1. Swingbench does not automatically rebalance the workload. Now we can force it to do that by killing off a bunch of those Swingbench sessions over on node 1. So I'm going to log into Swingbench. I have a little script which will generate those kill statements for me. And now if we go back to our Grafana dashboard, we just killed off 1/2 of the active sessions on node 1. We now see them reconnect to node 2. System load on node 1 has dropped, and now system load on node 2 is picking up as that workload balances out. What I want to do next is to add a couple of controls to my Grafana dashboard to track the read and write IOPS of the database. There's a couple of different places in Oracle to pull this information, and I recently wrote a blog post that explained the how and the where to find that information. In this example, I'm going to use the $IOStat file view. Now, this view tracks the small and large reads and writes against each file of the database for each active instance of a RAC cluster. It also tracks the throughput. So by summing up those numbers, I can get the total number of read IOPS and write IOPS of my database. Now, if I execute this query, you'll see that it crafts another Postgres insert statement into a table called IOStats file. So let's go ahead and execute that code. Now, the thing about the $IOStat file view is that the metrics recorded are cumulative, like the OS statistics that we saw from earlier. They're recorded from instant startup. So not only am I going to have to add this new data collector to my shell script that runs every few seconds, but I'm also going to have to calculate the deltas on the values as well. As before, all of the scripts and all of the code shown here are available from my blog and also from the GitHub repository linked in the description below. So next I'm going to add a new panel to my Grafana dashboard, and this time I'm going to select a gauge control. I'm going to set my data source again to my Postgres database. The table will be the IOStats file delta table, and the time column again is the TS column. And I want to look at the reads, and the system reports that we're getting about 3.4 million reads. Now that's a little higher than I expected, and that's because we haven't yet divided it by the elapsed time. So if I divide it by the elapsed time and call that reads and look at my query, the system now reports that we're getting 579,000 reads right now. And if I go and look at my backend PowerMax, that's actually pretty close to what the PowerMax is reporting as well, about 570,000, 580,000 IOs. This PowerMax right now is not doing anything but servicing our sample workload. Now, what I'll also do down here is I'll change out these thresholds. So I'll get rid of that 80% threshold, and we will add in a yellow at let's go for 500,000 on that, and I think we'll add another threshold at 800,000. We'll make that one red. These numbers are just entirely arbitrary. The backend PowerMax actually is capable of quite a lot more than that, but we just want to make it an interesting graph. And I'll also set my my maximum here to 900,000. Does that actually make sense? Yes, it does. Okay, and I should hit the apply button. And now we've got the panel there with, oh, and we changed the reads on this as well. Database reads. Okay, so I'm going to pull my panel down to the bottom here, and I will go in here and duplicate it, and on the duplicate version I will edit this and change it to database rights, and down here in my query I will change that to rights, and I should be able to run the query inspector, and there we get 306 database writes occurring right now. This is pretty much 100% read workload, and I will just drop these thresholds way down, just so that makes sense, and apply that. And that gives us a live reading of a database read IOPS and write IOPS. Okay, so I've got read and write IOPS. Now what I want to add to my panel is something to show me the throughput. So I'm going to change this now and add a new panel with a bar gauge. And again, data source will be my Postgres database, IOStats file delta, the time column again is TS, and I want to pull the read MBS. Let me go and edit that. Read megabytes per second, and I should also be able to do the writes. Apply that, and let's just change this around a little bit. So we're going to do the retro LCD, we'll go horizontal on that, and we'll change out these thresholds, get rid of the 80, and instead let's do 3000 on the yellow, and we'll add a 5000, and again we'll make that one red. And again, this is really just for making the graph more interesting. The underlying power mass can obviously do quite a lot more than this. Oh, let's also just make the maximum here as well. Make the maximum 9000 and apply that. And then I will drag that panel down. Oh, let's give this panel a more useful title. So this will be database throughput, and apply that. And there we have it, our Grafana dashboard showing us the backend system load on our two database nodes. It shows us our database host configuration, the number of connected users, and both the read and write IOPS and the current throughput at 4.3 gigabytes per second on the reads and 3.17 megabytes per second on the writes. Now if I go into Swingbench and shut this down, we can watch as those numbers drop as our workload wraps up. As Swingbench spins down, I will add that I've only just scratched the surface with Grafana. Even the free version has a very rich library of graphical controls to visualize your data and create sophisticated dashboards. For example, we could have included capacity utilization of the data files and table spaces, redo log switch rates or I/O latency. It's all possible, and if you have an interest, I definitely encourage you to explore further. And that's all we've got time for today. I hope that was helpful. If you liked the video, maybe click like, or even subscribe to the channel. Apparently that's a good thing, or so the smart people tell me. And as previously stated, all the scripts shown, as well as a complete description of what I did, are shown at my blog at grafdba.com, and I will include links in the video description below. Thanks, and I hope to see you all again before too long.